Okay, everyone, welcome back to 8.4, our chapter 8 lecture. Uh, Today we're going to talk about 8.4 and 8.5. And first, what we're going to do is we're going to do a separated parallel server. Instead of one test center, we're going to have 3 test center in that case. Also, for the tester, for the written and vision tester. Take a break every 8 to 12 applicants, so they have their specialized failure model. And this type of failure is not to the entire test center. It's just for the individual who run the test center. So for that purpose, we need to using 3 separate parallel server in that case. Let's do that. Also, to prevent waiting on the test center, make sure the input buffer capacity tests at station set to 0, and we're going to see the behavior for now. And okay, since now I have 3 different test center, we need to create a list and node list, which is the input node of all the tester, and then choosing the shortest line, which is also with no failure activation. So we can set up the routing logics on the output node like this. Okay, so this is what we plan on doing for 8.4 and 8.5. And 8.5 talks about blocking the flows. Test needs to be perform certain data entry after the test, meaning the applicant actually finish the test and leave, and however the tester actually who runs the test center stay for a data entry. So this need to be track the tester status. So we're going to set up a string state variable model level string state variable called gstat tester status, and this particular variable is a vector of 3 rows, 1 for each one of the test center. Initial state is available, and create 3 state status label on each one of the test center as well. Okay. So once the applicant serves, need to show the data entry for a period of time between 5 to 10 minutes, show available afterward. Okay, show available afterward. So we need to create a process data entry generic process. So we're going to first change the status to from available to data entry, and then we're going to delay for uniformly distributed between 5 to 10 minutes for the data entry. Then we switch back to the station status to available in that case. So using the process for test 1 and after processing and exit. Okay, so we see that. So we run with it after processing, doesn't leave until the process, actually the entity, the applicant does not leave until the process ends. So actually you hold off the applicant for the data entry as well. But if you run at the exit, the next entity can use the capacity of the server, and currently entity already leave, but next entity will not block and enter. So how we're going to do that? To prevent the next applicant entering the station during the data entry process, we need to cease the tester and prevent the next applicant to enter for that purpose. And we're going to change the input buffer capacity back to infinity, but entity travel to the server. We need to control the capacity of transfer nodes and namely output of the server registration. So we see how we can do that. So first, we're going to change the status from available busy to data entry. Then we seize the seize the tester parents. Okay, and we're going to delay for the data entry point of time, and then we're going to release the parents of the entity. Then we reset the status back to available. So we're going to see what is that. So the only thing very important is we're going to using a parent entity which would return the C's back to the model level. So the current entity can move on. Otherwise, the current entity will seize the tester. So they still stay in the tester center without moving on. So the ideal situation is after the applicant done with the test, the applicant actually move on itself and leave the tester stay busy for the period of data entry. So the staff member actually perform the data entry instead of applicant. So we need to pass on the C's portion from the associated objects to parent object, which means return the control of the C's to the model level, which is one level up. And so we show you in the model exactly. And also we need to block in the transfer, okay? If the blocking the path, if the tester is currently in the failure mode or is in the busy mode. Okay, so we going to do all these with. Finally, we're going to start talking about tokenized process that for data entry again. Actually, this current so-called data entry process, which is this process, is done only for the first tester. How can we generalize that into for all three testers? So we done this before. We're going to define a new token. We'll call the token tester, and we're using two variable defined for that token. The token basically is the mimic of the model entity, but it is an imaginary entity, have no physical meaning. But it carries two model, basically token level state variable. One is integer, which means which row number on that status we're going to access. The other one is object reference status, which tester to seize. Remember, we need to seize this tester and release them during the data entry process. So we need to know which tester to seize. So we're going to show you how to do that for that process. Okay, so we come back to detail all the steps. All right, go to the model now. So this is the model we leave off from the last class period. So we have 4 clerk, and for the registration, we're going to move them a little bit to the side so we have room right here. And we're going to get another one. So now I have 3 testing process. Okay, 3 testing process. So what I can do is I'm going to have a path. Path is about 5 meters. Okay, this is good. I'm going to connect the register to 3 tester, and going to connect the tester from here to that node. and from here to this node until it move along a little bit so you can see the difference. Okay. Now you see slightly difference. So from the output node of the registration, we divert them into 3 tester, and from the input node or output node of these 3 testers. So I'm going to have tester 1. I'm going to have this guy called tester 2. This guy called tester 3. All right. So we have 3 tester actually line up. And each one of them has a value pattern. Come over here to the reliability section. Okay. And the value is based on event, correct? The value is on the count basis. Okay, process count base, okay, is random uniform 8 to 12. For 8 to 12 applicants, I'm going to have a break. And the break is about 2 to 6 minutes. It's per distribution. Do this directly. So it's random per 2 to 6 minutes. All right. Make sure this is a minute setting. All right. So all of them has their own individual process. And how I'm going to forward the entity applicants from this output node of registration evenly to each one of the tester. We've done this before. So first we define the list. Okay. Sorry, this. This is a node list. Okay. The node we're going to have is called, oops, sorry, node list. It's called list of tester. And the first one is the input node of tester 1. Oh, sorry, it should be input node. Tester 1. Second is input node of tester 2. And third one will be input node of tester 3. So these are the candidate input node we have for 3 testing station. And now is the time to talk about how to divert the entity evenly to all these 3 testing. So here in the output node, instead of continue, we're going to select from the list, and this list will be list of a tester, and the preferred order is the smallest value first. Okay, smallest value first, and actually should be candidate, which is this candidate node. Sorry, candidate node. The candidate node has associated station low, which is the lower smallest one. Also, we need to be careful is only the one without value. So here we have a selection expression. This is very commonly mistaken in hiding like that. You make sure you turn it on so you can see this is the selection expression. Also, the selection condition should be something like the candidate server, value status, okay, active. And this is meaning the candidate server now currently is in the failure mode, and we don't want that to be selected. If this is happening, if the tester is currently in the on the break or in the failure mode, we don't want them to be selected. So this is pretty much what I have. Okay, and also we want to set the input buffer for all 3 equals to 0. So I'm not going to carry anything in my input buffer. Okay, so let's save and run our model, see what happens. You see that they're evenly distributed among those 3. Okay, I'm going to zoom in a little bit. Okay, problem. Sorry. I think their capacity should be 1 each instead of 3 for all. So let's do that one more time, see if we can run this. And you see that if these are busy right now, all these entities are queued up in the output buffer for this registration. I'm going to stop this and make it a little bit more visible for you. If I do this, you can probably see a little bit better. In the beginning, there's nothing queued up, but once I done that, you can see they start queuing up over here. Okay, you can start seeing they queuing up in the output node. We're going to utilize this output node as a waiting room for to get tests and so on and so forth. I will talk about it later on. Also, we're going to discuss how to using a label and introduce how to change the label for the data entry side process. I'm going to conclude this for now.